So, very good morning, dear students. Welcome back with me. This is Rajan Roy, and we are discussing standard and quality practices in production, construction, maintenance and services. तो चलते हैं आज हम लोग पहले सिक्स सिग्मा में डिस्कस कर देता हूँ. जस्ट आई हैव कंप्लीटेड yesterday सिक्स सिग्मा almost 50%. Those all things are there in this chapter, right? So open सिक्स सिग्मा चैप्टर, सी इन कंटेंट. जस्ट बुक में ओपन कर लीजिए सिक्स सिग्मा चैप्टर, राइट. और हो जाए ओपन, सामने आ गया तो प्लीज़ एक बार मैसेज कर दो डन. प्लीज़ मैसेज मी डन. फिर ये सिक्स सिग्मा चैप्टर करने के बाद हम पहुंचेंगे वापस से कंट्रोल चार्ट वगैरह पे. ठीक है. डन, वेरी नाइस. चलिए, तो इन सिक्स सिग्मा हिस्टोरिकल एस्पेक्ट्स देख लो. द टर्म सिक्स सिग्मा वाज क्वाइंड बाय बिल स्मिथ, राइट, फादर ऑफ सिक्स सिग्मा. कहाँ पे? मोटरोला में. लेट 1970s और 80s कह लीजिए. दे हैव एक्चुअली स्टार्टेड एक्सपेरिमेंटिंग प्रॉब्लम सॉल्विंग थ्रू स्टैटिस्टिकल एनालिसिस. और 1987 80s में बोला था मैं, Motorola officially launched its Six Sigma program, and due to the use of Six Sigma, Motorola is known worldwide as quality leader and a profit leader. The secret of their success became public knowledge after Motorola won the Malcolm Baldrige National Quality Award. This Malcolm Baldrige National Quality Award is given in USA for total quality management. But now you can tell कि sir this MBNQ award जो है, that is given for total quality management. In TQM chapter I will discuss this award. This will come again in TQM chapter. But it is given for Six Sigma. Actually, for quality, this is the highly coveted award, right? So just by looking their result and improvement, this award was given. When this award was given, then everybody came to know कि okay, that Motorola has done something special, right? Then see here, what is sigma and what is Six Sigma. So now listen, please, whatever I have explained yesterday, just read it and try to find whether you are able to get it or not, please. Right? Sigma is used to designate the distribution or a spread about the mean, right, or the average of any process or procedure. For a process, the sigma capability Z value, I have explained yesterday, is a metric that indicates how well that process is performing. The higher the sigma, means that Z value, right, capability will be better, right. Sigma capability measures the capability of the process to produce defect free output, means the higher the sigma at which you are working, means the higher Z, higher sigma capability, then the defective will be less. So how much defect free output is yours, that actually determined by the sigma capability, right everybody. Okay. Then what is Six Sigma? So Six Sigma is actually what is Six Sigma, we will see methodology and all, and I have explained you, but mainly influenced by TQM and zero defect. See, in 1980s they have started now, already before 1980s TQM was developed now, right, and that was the best at that time, yes, and zero defect, that crossways approach Zero defect, yes sir. So what Bill Smith has done, they have taken all the positive points of TQM and zero defect rigorous approach, right, and just developed Six Sigma, correct. This was the historical aspect. Then what is benefit of Six Sigma? So very simple, need not to memorize or read it even. See, if the defectives are very less, means 10 to the power 6 error opportunity, only 3.4 defectives, yes. So if the defectives are very less, of course your productivity is higher. Productivity is higher, then the cost will be very less, right. So now come to this point, 3 sigma, 6 sigma, I have explained yesterday these all things, can you remember? Whenever your working sigma or sigma capability increases, the area of the curve near target will increase, right, right. चलिए अब एक चीज और देखिए, द गोल ऑफ द सिक्स सिग्मा इज टू इंक्रीज प्रॉफिट बाय, सी हियर व्हाट इज गोल ऑफ सिक्स सिग्मा, what is goal of Six Sigma is to increase profit by, see लिखा है ना clearly, is to increase profit, means it is profit oriented. TQM, whenever I will teach you TQM is not profit oriented, my dear student, right. So here the goal of Six Sigma is to increase profit by eliminating variability, defects and waste, means not by cheating customer but by eliminating variations है ना, डिफेक्ट एंड वेस्ट दैट अंडरमाइन कस्टमर लॉयल्टी, राइट, क्लियर है. तो TQM तक मेनली हम लोग बात करते हैं कस्टमर फोकस्ड होने की, क्वालिटी इम्प्रूवमेंट की. ये बोलता है यस वी विल डू, नो प्रॉब्लम अबाउट इट, बट प्रॉफिट ओरिएंटेड होके करना है, राइट, मीन्स दे आर ऑल्सो गिविंग क्वालिटी ओनली, राइट. चलिए अब की सक्सेस फैक्टर फॉर सिक्स सिग्मा, committed leadership just like TQM, integration with existing initiative, business strategy and performance measurement, right, process thinking, disciplined customer and market intelligence gathering, correct, a bottom line orientation. See here, what is the meaning of bottom line orientation, right. This bottom line orientation means, this bottom line orientation means your, they are talking about money, correct, money, right, profit orientation and continuous reinforcement and rewards and the training, the rigorous training, whatever it is required is the key success factor. Like any management, everything was positive, two things are special, that is bottom line orientation means profit orientation, and in TQM we will study that is philosophy, correct. Philosophy, there is no methodology in TQM, we will study later, but here philosophy के साथ साथ methodology भी है, means apart from philosophy its methodology is also there. So which kind of methodology, I will explain it now. Before that, one term is there, DPMO, defects per million opportunity, right. It's very simple. In fact, parts per million you have heard na, yes sir, heard sir. To calculate hardness of water, yes or no, yes sir. So to calculate hardness of water, suppose I have written weight of hardness or salt, correct, divided by weight of water, correct. So actually we use it, right, yes, but this is very less in amount, correct, very less in amount, and water is huge in amount. So if you will divide anything with the very huge value, this will come to 0 na, yes sir. So to make it significant, correct, to make it significant, to make it make this value significant, what we do, we divide it by 10 to the power 6, correct, 10 to the power 6 means per millionth part of water how much it is, yes or no. So in the formula ये ऊपर चला जाता है, have you seen na, like this, yes sir. So don't write here, we write here. Actually what we are doing, we are dividing this by 10 to the power 6 so that per millionth part of water how much hardness is there, that we are going to calculate, right, yes sir. So, similarly defect per million, because the defects are very less, opportunities are more here. So, what we do? PPM. So, here DPM. वो तो चलो ठीक है अपॉर्चुनिटी, ओके डीपीएम रिलेट कर सकते हैं, यहाँ पार्ट्स है यहाँ डिफेक्ट है, पर मिलियन इज सेम. तो क्या हो जाएगा? एक्चुअल डिफेक्ट्स हाउ मेनी डिवाइडेड बाय एरर पर प्रोडक्ट, राइट, into number of products, right, into 10 to the power 6. So, now my dear student, defect error per product into number of products into 10 to the power 6. So, actually what we can see from here, this data is huge na, but defects are very less. Yes. So, by this calculation, when this is up to 3.4, correct, then it is called as Six Sigma management, that is the skill, correct. So, in your book also this is given, nothing to write. See, formula is given and one table is also given below that formula. You need not to memorize those table, right. What you have to do? You have to simply remember this thing, out of 10 to the power 6 error opportunity, you need to just have 3.4 defects, or even less than that, suppose 2 defect, 1 defect, all are called as 6 sigma only, correct. Near to 3.4, all are called as 6 sigma only, but 3.4 data is important, they may ask in the objective once they have asked already, right. ठीक है. तो similarly in bank they are using EPMO for quality control na, just I am writing here for extra information. In bank, right, there are thousands and thousands of transactions daily going on na. Suppose a large bank is there, correct, volume is more. So, they calculate EPMO means opportunity, but error per million. So, again what they do, actual error how many divided by error opportunity, total error opportunity into 10 to the power 6. So, they calculate it when it increases beyond a point, beyond a certain a specified label, then only updation is required. So, if any suppose app is there in your phone, then after 3 months, 4 months or 6 months, updation is required, correct, sometimes, and that updation actually needs sometimes more time. So, what they are doing, their EPMO has increased because customers are, correct, adding and adding, population is increasing, correct, and even their processes increases sometimes. So, error opportunities changes, correct. So, they update their system, they improve their system so that their error per million opportunity must be less than a value, correct, clear. So, this is simply a skill to measure whether you are working on 3 sigma, 4 sigma, 5 sigma, 6 sigma, which sigma, that is the skill, correct. Okay. Now, come to this is the formula already given, that in book formula is given clearly here, this is this, okay. Now, come to the Six Sigma methodology. I have told you in Six Sigma not only philosophy, methodology is also there, yes or no? Yes. So, Six Sigma works on 2 methodology, DMAC and DMATV. Sir, what is meaning of DMAC, sir? Yes. DMAC means in any process if you are applying Six Sigma, so first of all there you have to define. Sir, what we have to define, sir? Define means what is critical to customer, means customer के लिए critical क्या है, important क्या है, correct, that is define, okay sir. Then measure, just measure it, measurement, value of measurement is important, right, for accuracy, okay. After measurement, analyze, right, you have to analyze. Analyze means what was important, what was not important, where it is error or defect, where it is not, like that, correct. And after analyzing, suppose you need to improve something, because at analyze phase you will get to know yes, there is a need of improvement. So, improve it, correct. This improve stage is only DOE, or what you can say design stage, design of experiment it is called, but design stage. And after improvement again you need to control, that is your control stage or control chart, what we are going to study today. Getting my point? Yes. So, this is design stage, this is your control chart phase, means monitoring, with time you have to monitor, right. But before that you have to go through all these 3 steps sequence by step, right. Okay, sir. Then sir, what is DMA DV? Yes, this is also used in Six Sigma, that is first of all define the same thing, measure, analyze, same thing. But here improvement stage is there, here design stage is there, here control stage is there, here verify stage there. So, both are same only, the only thing is this is for new process, that is why you have to design and then verify first. But this is for existing process, this is for existing process, right, means already existing process, then you have to, right, do the DMAC methodology, right. I hope you got it. Even in the diagram, just below the diagram you can write for existing process, for new process, but the concept is same. Even for define you can write there only, in diagram only, because during examination you will not have time to read all the books and everything, but whatever I am marking, at least mark it, right. So, write down on the book only. Yes, Six Sigma, Sohani is asking, yes, Six Sigma chapter is given in the book, please open it. After summarizing it, again we will move to chapter number 3. Because Six Sigma chapter we have discussed yesterday, I have explained you how Bill Smith has given the concept, that is why. Okay, done. So, now come to the different levels in Six Sigma, correct. This is a kind of, right, what you can say expertise. In Six Sigma, whatever be your expertise, as per your expertise they will provide you work, they will assign you work, they will give you your domain, correct. So, simply it is at the top of this pyramid you can see the master black belt is there, and here champion, who is champion I will explain, then black belt, green belt, then team members yellow belt and all, right, yellow belt, white belt, right, like that. So, now try to get with my example, I am giving you one example, very simple. See, this master black belt is just like your coach or technical advisor, right, who is having a lot of experience, right, a lot of experience, just like in cricket team coach is there na, yes. So, that is the master black belt. Okay, sir. Then master black belt, coach is playing cricket or not? No, sir. Coach is only there to give mentorship to the players. Agreed? Guidance to the players. Suppose BCCI wants some suggestion, then coach will again suggest BCCI, right? Means any kind of cricket knowledge or cricket expertise is needed, that is delivered by coach. Okay, sir. Then who is the team leader over there? Sir, captain, sir. So this is your captain, correct? This is your captain. Suppose Rohit Sharma or Virat Kohli, just name it, no problem. So what is responsibility of captain? Sir, to lead the team, sir. Okay, yes. Not only to lead, but also, correct, to give task to team, what is their responsibility in Six Sigma while execution. Yes or no? किसको बॉलिंग करनी है, किसको बैटिंग करनी है, ये ग्राउंड पे who will decide? Sir, captain will decide, sir. Just like that, black belt kind of team leader who is going to decide what is their roles and responsibility, correct, while execution. Okay, sir. And then in green belt, yellow belt, these are some senior player like that, but these are player only, correct? And this is some junior player like that, right? Just like I've given the analogy so you can understand. Like suppose this is Pandya and all, correct? And this is some new player, suppose has joined, Ishan Kishan and anybody, correct? Like that. Okay, very simple, na? So this is the hierarchy, means the kind of expertise you have, right, you will be assigned to that kind of work. Simple. Sir, who is champion, sir? Okay, champion means BCCI. Simple. Means the sponsor, your sponsor, correct? Champion means your sponsor. Means whatever money or whatever manpower captain needs provided by BCCI. Decision taken by BCCI with the help of advisor, coach. Yes or no? But decision taken by whom? BCCI, right? Whatever money, whatever resources, whatever player, correct, which kind of player they want, correct, that is decided by BCCI. Yes or no? Yes. So this kind of structure there is in Six Sigma, means champion sponsor means you can you might have understood like of your top management, kind of top management. But now you can ask, sir, this is here also, sir. Yes, top management means not only top management but middle level management, lower level management, but all are actually following instruction of top management only, right? All are following instruction of top management only. That is the meaning, correct? I hope you got it. Their roles and responsibility. Yes. Now come to the definition, then you will exactly get my point. See, who is champion and sponsor? Decides what needs to be done, means decision taken by champion to be done, and provides the assistance to the black belt both with monetary resources, matlab paisa, as well as dedicated staff. Very simple. In addition, this position benchmarks with other organization. Yes, I have told you, na, benchmarking is also a process in which we take the data from the best resources. So that is also done on the top management level, correct? Because a company will not share data to the other company's employee, right? So this is on upper level. In order to gain key information in processes, they may need to improve, right? Okay. Now come to the master and master black belt. Just see the example, you can understand. Instructor, coaches, technical leaders and all, right? A person who is at the highest level of expertise on the subject, they are fully devoted to the process and have no other job responsibilities outside the methodology, right? Okay. Now come to the certified black belt. See, black belt, at the place of black belt you can write down captain, right? See, captain exhibits team leadership, understands team dynamics and assigns their team members with roles and responsibility. See, बिल्कुल फिट बैठ जाएगा, आप ऐसे करके समझ लीजिए, कभी नहीं बोलोगे. They have a complete understanding of DMAC, yes, model in accordance with Six Sigma principles. Have a basic knowledge of lean. See, because that black belt or the captain has to decide, has to, they are going to assign their team members the roles and responsibility. That is why, my dear student, there must be a little bit knowledge of lean is required for the leader, because they must know what is for value addition, what is not for value addition, correct. So, these kind of concept is there, right. Next come to the green belt and all, these are the actually team members, right. Already you know, I have given example, they have their specific work, you have to do this work, right, in your domain, like that. Then yellow belt, the junior one, correct, means new one, not junior, new one, new person, like that. So, what is future of Six Sigma? Because what are the disadvantage of Six Sigma? Means what is the limitation of Six Sigma? Limitation is a use of initial investment is required, correct. So, its future aspect is lean concept, right. I have just in introduction only I have given you, I will explain lean, correct. So, see here, the methodologies to implement lean is, first of all, understanding customer value. 5 things are there. Whenever you will get training of lean, 5 things are important. The very first thing is, first of all, understand customer value. Because if you will understand customer value, then only you can do value stream analysis, point number 2. And if you will do value stream analysis, then you can determine which one actually add value and which one not able to add value, right. Then the third is material management. MRP and JIT, we have studied 2 kind of material management, yes or no? Yes. So, lean supports JIT, means focus on organizing a continuous flow through the production or supply chain rather than moving commodities of in larger batch size, means they are not supporting to move commodity in larger batch size, but they want continuous flow, means just like JIT, correct. Because in JIT also, just whenever there is a need, take it, do not purchase it in larger batch size, correct, just like that. And here pull, right, MRP was push approach, means you are forcing material into production. JIT, the pull approach, means already you have pulled the material on only whatever is required you are giving, like that. So, prevent a stock, means there is no stock, correct. Then perfection. Perfection means only one thing, quality improvement, continuous quality improvement, and or what we can say, elimination of non value adding element, that is waste, correct. And it is a process of continuous improvement, very simple. So, point is, what is difference between lean and Six Sigma in simple word. So, lean makes you efficient and Six Sigma effective, both are different. See, efficient means your speed increases, you are doing the same work with optimum resources, that is efficiency, and effective means whatever you are doing, that is perfect, that is okay, less defects are there, that is effective. So, the focus of lean is about a speed, efficiency and taking waste out of the process, whereas Six Sigma focuses on effectiveness, correct, and removal of error. Getting my point? So, you are correct or not, that is Six Sigma, but to become correct, how much resources you have used, how much time you have taken, that is the lean. Getting my point? In paper also, whenever you attempt your test series, my dear student, or your paper, correct, try to get those questions who are very lengthy, right, and it will take more time, do not attempt them, correct. Try to leave those questions as fast as possible. Means, see, in cricket, when a fast bowler is there, only by looking to see, batsman is not able to see the ball, correct, the speed of ball is too much. So, just by looking from this point only, correct, the batsman will decide whether they have to give a stroke or they have to just leave or defend. So, just by looking here only, if they will delay, correct, then can be bowled, right. So, point is, just by looking question, try to get first of all whether it will take time or not. If it is taking time, then attempt in later. So that is lean concept. Means which question is for your value addition and which is not. So don't instruct on those questions which is lengthy and there to just disturb you, distract you. Correct? Chaliye. In GS paper there is no problem. I repeat, in GS you will get ample amount of time. But in technical, whatever I have just suggested you, that is for technical. In GS paper, either you have to leave the question or you can solve. In GS time there is no problem of time. So what is 6 sigma plus lean? 6 sigma plus lean is equal to lean 6 sigma. So this is the future of 6 sigma, means effective के साथ साथ हमें क्या बनना है, efficient भी बनना है. Right? Clear है? अच्छा. So this is all about your 6 sigma, correct? Already most of the things we have studied yesterday, that is why I have completed it. Now when suppose we'll discuss that quality control tools, then we will see which tool is used for define phase, measure phase, analyze phase, means in DMAC which tool is used for which phase. So again you will understand there easily. So now come to the again to that point where already we were, correct? See, variable control chart and attribute control chart. Can you remember these all things? Right. So today we are going to discuss control chart, their uses, process capability, capability ratio, like that, correct? Okay. So now control chart again two type, variable attribute I have explained you yesterday, right? Whatever kind of data is there, name is actually associated with the data, right? So here variable data, variable control chart, attribute data, counted data, control. Then mean and range, P chart, C chart, like that. Now come to the variable chart. Please revise it once, then I will just move ahead. एक बार देख लीजिए. right? Already this thing we have discussed yesterday, just once you go through. Done? Very nice. ठीक है, अब मैं आपको थोड़ा सा कंट्रोल चार्ट का आइडिया देता हूं, राइट? सी, इन कंट्रोल चार्ट एक्चुअली what we have to do, we have to draw 3 lines always in all control chart. Try to understand, correct? We have to draw 3 lines, this and this, 3 lines, simple. Okay sir, so how to draw 3 lines? Actually data is given na? Yes, data is given. Yes sir, data is given, correct? So with the help of data we will solve problem also. Just with the help of data we have to draw. So first of all, the first line you have to draw is control limit. This is the first line you have to draw. Sir, what is that control limit? The control limit is nothing but average of given data. Means whatever data is given, like see, in average control chart which type of data will be given? Average sir. So do average of that average data. Okay. In range sir, so range. In P chart, proportion defective chart, what is name? Proportion defective. So take average of proportion defective. Then in count of defect, yes, defect counting is there sir, 3, 4, 5. So take average of that. Means whatever is the name of control chart, correct? That data will be given, and that data will be given, just take average of that data, you will get this line. Very simple, right? Okay sir. Then add something and subtract something. Sir, what is something sir? Okay, so suppose we are working on 3 sigma, then add plus 3 sigma minus 3 sigma, but here this sigma is not process standard deviation. No. This is sample standard deviation. Means this data is given, means actually sample is given, sample inspection has been done, and from there data is given. So this standard deviation is actually standard deviation of sample, right? Standard deviation of sample. So now you can ask, sir, standard deviation of sample means, sir, means the standard deviation which is calculated from the data. So I am writing here, sample standard deviation means standard deviation calculated from sample. Means I am writing here depends upon sample. Means if you have changed the sample or sample size, then this will change, correct? Depends upon sample. But what was the answer? This standard deviation, sir, actually this was a standard deviation of process. means it will not change by changing, correct, does not depends upon सैंपल, ये सैंपल पे डिपेंड नहीं करता है, राइट। स्टैंडर्ड डेविएशन ऑफ द प्रोसेस, ये किस पे डिपेंड करता है, प्रोसेस पे डिपेंड करता है। तो अगर आप डिफरेंट डिफरेंट सैंपल्स लेते हैं, करेक्ट, इफ यू आर चूजिंग डिफरेंट डिफरेंट सैंपल्स, then this value will not change for a process. Yes, this will change. Getting my point? So here what we use standard deviation of sample, not process. Then sir, what is use of a standard deviation of process, sir? Oh, I will explain later, just wait. Okay, okay sir, done sir. Now tell me, in each chart, suppose x bar chart is there, range chart is there, correct, then your p chart is there, yes sir, and c chart is there. So all chart are different from each other, na? Yes sir. So their standard deviation of sample calculation is also different. Like, see here in x bar chart, what we do, again this formula and everything is given in your book also, but in short I am giving you entire idea, and then I will apply to the numerical problem, then you will get exact idea. Getting my point? So before solving a problem, I am giving you small idea. See, so here standard deviation, correct, standard deviation of the sample is calculated by, see, is calculated by, this is sample standard deviation, calculated by standard deviation of the process divided by under root small n. What is a small n, sir? It is sample size. What is sample size, sir? It is the number of elements, number of observation in a sample. How many? Suppose n. So this is called as sample size. Getting my point? Already this is there in the book. You can see in book also, otherwise you can focus here. In range chart, what we have to remember, sir? So in range chart, few extra things are written in your book. Don't look them. Only what you have to do, that standard deviation of the process we need to calculate here, that is R bar, means average of range, divided by D2. What is D2, sir? D2 is constant which is given in the problem experimentally, correct, given experimentally, means we cannot conclude it, this is given experimentally, right. It also depends upon sample size, means if sample size is different, the constant is given some different value. So this is given in the question, right. So we will use also it. Then what is that for p chart, sir? Okay, so for p chart, the standard deviation for the sample for p chart is actually under root p bar into 1 minus p bar divided by n bar. So what is p bar, sir? Of course average, already you know na, what is average? Average means just you have to put the bar on the data given, correct. Okay, so in C chart, sir, so in C chart already we have seen in the table we are using Poisson's distribution, yes sir. So in C chart we know that the variance, yes sir, is equal to mean, na? Mean means average, yes sir. So this is equal to a standard deviation ka square, yes or no? Yes. So for sample we can calculate this standard deviation of the sample by taking under root of the mean simply. So my dear friends, these are 4 formula what you have to remember simply, because everywhere the concept is little bit different, that is why their formula is also different. So write down this first in a short kind of short note, so that for revision it will be easier, then I will solve the problem. So first of all write down this. Okay, completed everybody. So now my dear student, you need not to remember any extra formula, extra thing apart from this, right? Only this thing you have to remember. Means what we have to do in each case, right? First of all, we will have to take the average, right? Average. Here it is P bar is again the average. Getting my point? R bar is the average, right? And here also this X bar is the average, or average data is given, we need to calculate grand bar. Grand bar means the average of the average data. Okay, fine, no problem. So everywhere we need average, and then by applying these formula, we will have to get this standard deviation of the sample, and as per that data, we will use it, correct? Okay, sir. So now I'm just directly taking you to the numerical so that you can have better understanding of this concept, right? One more thing before going into numerical, P chart is having a special case also. Means when the number of sample size is same, right? And what is small n? Small n is the sample size, correct? So suppose there are many samples, so this is the average of all the samples, right? Okay. So but if the sample size is same, correct? I hope you have written this. That is, I have given in your book. Nothing to worry. But still, once I am just explaining here, correct? Suppose in P chart I am giving if n1 is equal to n2 and so on is equal to n. Sample size is same. Sample size is same. Suppose your sample size is same. Then my dear student, if the sample size is same, then what we can conclude here, that the formula will change a little bit, that is called as NP chart. That chart of name is NP chart. See in your book also, after P chart it is given NP chart. So what is control limit there, that average point, that is NP bar, means not P bar but NP bar, because it is NP chart now, na? So NP bar, simple. Then what is your this standard deviation of the sample in case of NP bar? That is equal to under root, see the trick, multiply n with P bar, means for P bar it is P bar into 1 minus P bar, yes. So for NP bar it is NP bar into 1 minus P bar. So this is the standard deviation of the NP bar chart, correct, in case NP bar chart. So what is change? If the sample size is change, means same, means n1 n2 all are same, so its average will be same only, na? This is, if the data is same, so average will be that data only. So only change in formula is, you need not to apply this but this. The change in control limit means middle line is, you need not to apply P bar but NP bar, right? That is there in book also, but just I have written. So now if you want to write there, write it, correct? Write it. So I can solve the problems so that you will have better understanding of the idea. Just I have taken few problems from the industrial manual so that directly we can see how process control can be done and we can conclude it. Means very simple problem. चलिए, I hope ये हो गया होगा. हाँ यस शोएब, कोई बात नहीं, जो लोग लेट ज्वाइन किए हैं कोई परेशानी की बात नहीं है. इन मॉर्निंग आई हैव एक्सप्लेन्ड 6 सिग्मा चैप्टर, राइट? ठीक है, नथिंग टू वरी. वट एवर वी हैव स्टडीड yesterday, I have shown it in 6 sigma chapter, chapter number 7 I think in your book. So okay, you have joined in 6 sigma only, right. Done, very nice. So now come to the yes, suppose this is a simple problem. In your book also this is given. In book, just see the last part, question number I think 5 book में देख लीजिए एक बार. Don't write, just see in your book only, back side, right? Few objective questions are there, na? See there, I have given this question. Now tell me, first of all, can you reply me? Which kind of control chart has been we have to use here? Reply me after just seeing the question. Reply me which control chart is used here, please. बताइए. Right, कस्तूरी दास. वेरिएबल. अब दिस इज द फर्स्ट स्टेप इज करेक्ट. इसमें हम वेरिएबल कंट्रोल चार्ट यूज करेंगे. वेरिएबल में कौन सा बताओ, एवरेज या फिर रेंज? क्वेश्चन को पढ़ के बताओ. विच करेक्ट, इन दोनों में कौन सा, एवरेज और रेंज? वेरिएबल इज द राइट आंसर. एक्स बार चार्ट और एक्स चार्ट, करेक्ट. सो दिस इज द राइट आंसर. वेरी नाइस, थैंक यू. चलिए, मतलब देखो, इन क्वेश्चन ओनली इट इज गिवन मीन डायमीटर. देखो क्लियरली मीन किसका नाम है, एवरेज किसका नाम है, एवरेज कंट्रोल चार्ट का. यस और नो? यस. तो मीन डायमीटर इज गिवन दिस मच, मीन्स सपोज x1 और यू कैन रिप्रेजेंट बाय x1 बार 0.5230 centimeter is given. Now and a standard deviation is given, so a standard deviation is 0.0032 centimeter, right? So why I have given this question? Because sometimes simply a standard deviation is given, they will not write whether this is a standard deviation of the process or a standard deviation of the sample. So what we have to do, sir? So if simple standard deviation is given, you need to take it a standard deviation of process. This is the convention, kind of convention. But suppose in examination, by putting a standard deviation of the process, you are not getting the option, then don't be adamant over there. Just think, okay, this might be a standard deviation of sample also. So just take it a standard deviation of the sample. Getting my point? Because in paper on first page they write, take whatever assumption is required, suitable assumption is required, correct? So you cannot take any allegation or you cannot give, correct? You cannot challenge the paper in court, correct? Because of this line. So better, first of all, if nothing is given, right? So standard deviation take as a process. If by putting as a process we are not able to get the result in options, then take as a sample. But here I am taking as a process because that is the convention. So now tell me, here they are asking the 2 sigma UCL and LCL for mean of sample 4. So what is sample size? 4, right? मतलब एक सैंपल में कितने हैं डेटा? 4 डेटा इज देयर, राइट? Okay ji. Then how many samples are there? Sir, only one, sir. Suppose x1 or x1 bar is 0.5230. So what is their grand average, means control limit? Sir, 0.5230 only, sir, because if one data is there, so average of that data is also same, sir. Okay, very nice. So now what is that sample standard deviation? Sir, process standard deviation divided by under root n, sir. Don't write, the solution is also given in your book, correct? So this is your sigma x bar. So upper control limit and lower control limit, right? For 2 sigma they are asking. So 2 sigma means try to understand what we have to see. See here what you have to apply, 2 sigma x bar, and here plus minus 2 sigma x bar, means we are working on 2 sigma, they actually given mentioned in the question. If they are not going to mention this limit, sigma limit, then what we have to do, sir? Then by default we will have to take 3 sigma, my dear student, right? So now what will be the answer? So upper control limit and lower control limit is equal to that 0.5230 plus minus, right, 2 into that 0.0032 divided by under root 4. Very simple, correct? So, in this way you can find the result in objective questions, correct? So, that is given in your book also, solution is given, please see that. Yes, right, मोहम्मद सकीब, यू आर राइट, 0.5262.51, ठीक है, करेक्ट। चेक कर लीजिए एक बार, आंसर बुक में भी गिवन है, चेक इट। चलिए, I hope if anybody want to write it, otherwise we will move ahead, correct? So, please message if anyone is writing, otherwise I will move ahead. Actually it is mentioned in book also, so no need to write, but still. डन, थैंक यू, थैंक यू। चलिए अब एक काम करते हैं, ठीक है, दिस क्वेश्चन इज इन फ्रंट ऑफ यू, राइट? फर्स्ट ऑफ ऑल note down the question, please note down the question, right? And here actually it is written draw the NP chart, but suppose it is not given, are you able to identify or not, tell me, right? Means what is the point, what you can see here by which you can decide yes NP chart is there, right? So please tell me, first of all write down the question, then I will conclude. Please write down fastly. Right, Manjeet, you are right. Same samples daily, correct. So, same samples daily, it means correct, NP chart. But first of all, tell me P chart, C chart, how you are going to differentiate whether it is P chart, C chart, mean chart, range chart, right? Which chart you have to apply. Then we will see the same sample size and NP chart, that is fine. But what is the key point? What you are going to see, for which chart you have to apply here? That is my first question. Then we will see for NP chart. Yes, Ruchi, right answer. Thank you. Ruchi Agrawal, correct. Right. Numeric data. So if numeric data is there, it means attribute control chart. Very nice. Yes. Correct. Kasturi Das or Acharya, you are right. Numeric data. Gurudeep, you are right, but why you are writing C chart? Means this is defective, here it is defective, na? In C chart, that is count of defects. Here, number of defective blades. So there is a difference, na? In C chart we write defects, in P chart we write defective, right? रोग और रोगी बताया था ना, याद है कि नहीं? Disease and the patient. I hope you have written the question. क्वेश्चन लिख लिया? पहले बताओ जल्दी. क्वेश्चन लिख लिया तो प्लीज मैसेज मी डन सर, सो दैट आई विल मूव अहेड. Okay, so you have written the question. Now see, now I am explaining. BHEL, you have heard na BHEL? Yes sir. So suppose you have visited BHEL and there turbine blades, correct? Turbine blades are there na? Yes. So turbine blade manufacturing was going on. From that lot, 1,000 blades are examined daily. Suppose 1,000 blades they are randomly taking as a sample and then they are examining those blades, right? And first day what they found, 9 defective blades are there out of 1,000. Second day again 1,000 blades taken, 10 defectives, and so on. For 15 days data is there, right? Now suppose they have asked you, okay, tell me, do you know process control, how process control can be done, can be seen whether the process is under control or not? Yes, you can tell, yes, I have studied from Rajan sir, yes, okay. So now, my dear friend, first of all, sample size is same na? Yes, daily 1,000 blades, and here defective, see the keyword defective. Defective means you have to think for P chart, and sample size is same, so this is NP chart. Getting my point? Sample size is same, so NP chart. Okay sir. So what we have to do sir? Very simple. In 2 lines you can get the answer. How sir? Okay, see. First of all, what need to calculate sir? I need to calculate sir 3 lines sir. This is my target sir. This is control chart sir, because this is give, correct? We are going to monitor defects sir daily, on daily basis sir. Okay, perfect. So now my dear student, the point is, first of all we need to calculate this control limit, that is NP bar. correct? So what is NP bar, or first of all tell me what is P bar? Sir, P bar is the average of this defective, sir, right? Right? So out of 1009, so what is, see, we need to take average of proportion defective, right? Because this chart is named as proportion defective chart, correct? So take the average of proportion defective, okay sir. So what is average? That is 9 by 1000, yes sir, plus 10 by 1000, yes sir, and so on, divided by total how many data? 15, sir. Okay, so this is your P bar, and don't calculate it, just simply when you will multiply with again n, right, sample size, then this 1000 will get cancelled. So anyway, this is your P bar, yes sir. So what will be NP bar? So NP bar is equal to, sir, just we have to multiply with 1000. So when you will multiply with 1000, this 1000 will get cancelled, na? Yes. So simply 9 plus 10 and so on divided by 50, correct? So how much it is? I think 11, na? Near about 11. Okay. So finally you got your NP bar, that is 11, suppose, correct? Approximately 11. Okay. So now what you have to do? You have to add something, subtract something. Nothing is given, then what you have to do? Plus 3 sigma NP bar minus 3 sigma NP bar, right? So what is sigma NP bar, sir? So again you have to apply those formula, right? I am writing here. What is sigma NP bar here? Sir, that is equal to NP bar. NP bar is how much? 11 into 1 minus 0.011, that is P bar. So suppose you are getting something like this. So what is upper control limit? This is called as upper control limit, this is called as lower control limit, right? This middle line is control limit, this is upper control limit, this is lower control limit. So what is upper control limit? Sir, upper control limit is nothing but, sir, this control limit 11 plus 3 times sigma NP bar. So okay, just you can put it. So you will get this 20.89 approximately. What is lower control limit? Lower control limits are 11 minus 3 sigma NP bar. So that is, I think, 1.105 or something you will get. Okay. So what is this? What is this? This is 11, sir. 11. I am writing here 11. What is this? This is 20.89, sir. What is this? 1.105. Suppose by calculation you can get it. See, this is not a question of objective, right? This is a men's problem, but I have given you because I want to make you understand, correct? What is process control, how it can be done, what conclusion can be taken from here. So now my dear student, suppose you have marked all three, then simply what you have to do, you have to just put the values 9, 10, 12 and all. So I am going to put these values. See, 9, ये 11 है ना, तो पहले दिन 9 था, सपोज 9 यहाँ कहीं दिखा देता हूँ 9, देन 10 अगेन लेस देन 11 है, देन 10 के बाद 12 is here like that. So just you can draw these things, whatever data is there, correct? Draw all the data. Okay sir, when drawing all the data, correct, what will you find here? Sir, finding is not a single point is crossing the limit, sir. So first condition is satisfied, not a single point is crossing the limit. Second point, whether these data is increasing or decreasing. No sir, this data is not increasing, decreasing, sir. This is random, sir. So now you can see, sir, here it is increasing, sir. So don't see few data, just at least 4 or 5 data at least should be there, and that too in a single range, correct, like this. So that is not the case here. So what we can conclude ki sir, the process is under control, means two conditions you have to check, whether at least one point is crossing the limits. No sir. Okay. And whether the pattern is increasing or decreasing. So no sir, pattern is random. So the process is under control. So what is meaning of process is under control? Sir, process is under control means it is not telling you quality of the process. Getting my point? No. Don't think about quality now. It is telling you about the variation, about the causes of variation. Means the defective blades are there na? Yes sir. So what is the cause of these defective blades? So cause of this defective blade is random variable, because process is under control. So they are actually giving hint towards which kind of variable is the cause of this defective blades, random or assignable. मतलब बॉल बाउंड्री लाइन के बाहर जा ही नहीं रहा है, मतलब जो भी प्लेयर है उसका एम्पलीट्यूड कम है, सिंगल सिंगल डबल सिंगल लेकर के खेल रहा है, like that. Getting my point? So that is why those are random variable. If it was assignable variable, if it was, suppose, assignable variable, so in assignable variable amplitude is large, then the variation in data will be large, and then this data will cross the limits. So here not crossing means no assignable variable. So simply we have to comment the cause of variation from the control chart. Then you can ask, sir, then how we will find quality of the process, right? Customer is getting good product or not? This discussion from where we are getting. So I will discuss it later from a different problem, right? First of all, tell me everything is clear or not, means just whatever I have done the calculation. See here, you are able to get it or not? So any पूछ रही है, sir, can you tell again how to identify which chart need to select after showing any question? डेटा देखो ना, डेटा कौन सा दिया हुआ है, चार्ट का नाम पहले आपको आना चाहिए, एक्स बार चार्ट, रेंज चार्ट, प्रपोर्शन डिफेक्टिव चार्ट और काउंट ऑफ डिफेक्ट चार्ट. तो नाम में ही लिखा हुआ है ना कौन सा डेटा है, उसका नाम जो है ना वही डेटा होना चाहिए, तो वो चार्ट होगा. वेरी सिंपल. मीन चार्ट है तो मीन डेटा होगा, रेंज चार्ट है रेंज डेटा होगा, प्रपोर्शन डिफेक्टिव है तो डिफेक्टिव लिखा होगा, काउंट ऑफ डिफेक्ट है तो डिफेक्ट लिखा होगा. वेरी सिंपल. So please complete the solution and then I will give in comment whatever I have just explained now, whatever I have concluded now. Nishtha is asking, sir, number of samples same कैसे देखे? अरे 1000 ब्लेड्स ही डेली एग्जामिनेशन हो रहा है ना, करेक्ट? तो जब 1000 ब्लेड्स डेली एग्जामिनेशन हो रहा है तो सैंपल साइज सेम हो गया ना, हर दिन 1000 ही है. अंकुश पूछ रहे हैं 11 कैसे आया? एवरेज तो लेना आता होगा अंकुश, एवरेज ले लो ना, देख लिखा तो है. पी बार निकाला है, एन पी बार मतलब इंटू 1000 करोगे ना इसको. नहीं शोभित, नहीं आते हैं, ठीक है, मैकेनिकल से इसको निकाल दिया है, मैकेनिकल के सिलेबस से. These are not in your mechanical mains syllabus, right? देखो P बार अगर ये है तो एन पी बार क्या होगा बताओ. P बार को 1000 से मल्टीप्लाई करोगे ना, तो जब इसको 1000 से मल्टीप्लाई करोगे तो 1000 कैंसिल नहीं हो जाएंगे. सिंपल मैथ है. Yes, Avilas, I know that all calculation are correct. कंप्लीट हो जाए तो बता देना कि डन सर। सचिन पूछ रहे हैं 0.011 कैसे आया। देखो पी बार जब निकालोगे ना ये वैल्यू, ये आएगा 0.011, ठीक है। वो जो फार्मूला होता है जब आप देखेंगे घर पे रिवीजन करना, तो सिग्मा एन पी बार इज इक्वल टू 1 पी बार, एन पी बार तो है ही, 1 माइनस पी बार आएगा, ये फार्मूला होता है। तो पी बार है ये, और ये पी बार कहाँ से आया, ये कैलकुलेट करके आया, ठीक है। अरे टेक्निकल पढ़ने के बाद सब इंजीनियर ही तो हो, इतना मैथमेटिक्स नहीं आ रहा तुम लोगों को। टेक्निकल इतने टफ टफ सब्जेक्ट पढ़ते हैं, ये 2 लाइन का है, इसको समझने में तुम्हें दिक्कत हो रही है। यू हैव गॉन थ्रू ए स्ट्रक्चर मशीन्स, है ना, फॉर डिफरेंट डिफरेंट ब्रांचेस आई एम टेलिंग, करेक्ट। सोम एंड एनालॉग कम्युनिकेशन, और उसके बाद तुम्हें ये 2 लाइन नहीं समझ में आ रहा। ओके डन एवरीबॉडी, ठीक है। अब जरा नोट में लिख लीजिए, नीचे कंक्लूड कर लीजिए, कंक्लूड कर लो। नॉट ए सिंगल पॉइंट इज क्रॉसिंग द लिमिट्स, not a single point, not a single point is crossing the limits, is crossing the limits, and pattern is random and hence process is under control, means the defectives are due to 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 due to random causes, or or common causes, or common causes, right? Random causes or common causes. Matlab, I have explained you, defectives always will be there. Few defectives will be there always, right? Even in the best process also. Because random causes are always there. You cannot 100% remove your random variables, right? So, but our intention is we have to see, the production team has to see whether the process is under control or not, is their duty actually, right? Means there should not be any error with assignable variable, very simple. Common variable, yes, it will be there, this is the part of the process, right? Okay, sir. But sir, I want to suppose I want to improve my process. Yes, you can, of course. But for that discussion, I will take another question. Here only we have to see whether the process is under control or not. Means the cause of defective is random or assignable. Only this, nothing more than that. What is quality, good quality, bad quality, nothing can be seen from here, I repeat, right? So here only we can see the process is under control or not, means the defectives are due to random causes or assignable causes. So control chart only tells us the causes of variation. क्लियर है? याद रखना, ये भूल मत जाना. चलिए एक काम और करते हैं. ये क्वेश्चन है, राइट? पहले क्वेश्चन पढ़ लो, फटाफट लिख लो, करेक्ट, राइट डाउन and reply me which control chart has to be applied, correct, here. और इसको सॉल्व भी करना है, सॉल्व भी कीजिए, राइट? पहले क्वेश्चन, राइट, यू आर राइट, यस, कस्तूरीदास आर आचार्य, राइट, यस कस्तूरी, सी चार्ट इज करेक्ट, C chart is the right answer. Very nice. Why? Because you have to see simply the data given. See here, number of defects. This is the keyword. Correct. Very nice. Yes. Yes, Karthik, you are correct. So always try to see the data and just you can have idea कि अच्छा ये chart यहाँ लगेगा. Right. C Sharma, correct. You have explained it. Numeric data, so attribute chart and defects, so C chart. Very nice. Very nice, very nice. So almost each and every student has replied C chart. Very nice. Correct. So now you got it. Correct. So this is the trick. Whenever you apply trick ना, you will get result easily. चलिए अब इस क्वेश्चन को लिखिए और हम सॉल्व करेंगे. Abhishek Singh Negi is asking something. Abhishek, this we will get it in next chapter, right? We will discuss whatever you are asking now, that is coming in next chapter. Okay, okay. So Sakib has replies under control. Very nice. See, first of all, in this question, try to get the concept. In a cloth manufacturing mill, correct, 100 square meter cloth is taken as 1 unit, suppose. So 100 square meter के कितने लिए गए, 10 units लिए गए. So in first 100 square meter cloth there are 2 defects found. Counting can be done na? Yes. In second unit 3, third unit 1, and so on. Okay, sir. So now you have to comment, right, ki whether this process is under control or not. Again, what is meaning of process is under control or not? The meaning of this is the defects are due to random variable or assignable variable. Only this thing we have to comment. करेक्ट? यस सर. चलिए चलते हैं डिफेक्ट चार्ट्स. डिफेक्ट्स है तो सी चार्ट हो गया, समझ में आ गया होगा. यस, तो चलो बताओ. सी हियर, सी ऑल द फॉर्मूला आई हैव रिटन ना. सी चार्ट देखिए, जस्ट मीन वी हैव टू टेक द एवरेज. एवरेज के बाद दैट इज इक्वल टू स्टैंडर्ड डेविएशन का स्क्वायर, बिकॉज हियर which distribution is used? Poisson's distribution, correct? So in Poisson distribution, variance is equal to mean. Already you have studied in mathematics also, right? So now come to the point. See, so only what we need, sir, 3 lines, sir. Control limit, upper control limit, lower control limit, right? Yes. So what is control limit? C bar, sir. So what is C bar? So how many defectives are there? 2, 3, whatever it is, correct, divided by how many data? 10 na? 10. So I think it is 2.3, correct. So this is 2.3. Now what we have to get? Plus 3 sigma C bar and minus 3 sigma C bar. So here what is sigma C bar? Sigma C bar is equal to under root C bar, under root 2.3, right? So what is upper control limit? That is control limit means C bar plus 3 under root C bar. How much C bar is? 2.3 plus 3 into what is under root C bar? Under root 2.3, correct. And then what is lower control limit? C bar minus 3 under root C bar means 2.3 minus 3 into under root 2.3, that is minus 2.2. So I especially I have taken this question. Suppose sometimes in calculation it is in negative with negative sign, then take it 0. Don't take it negative, because negative defect अपने तरफ से कर थोड़े न दोगे उसमें, correct? तो negative defect means 0, correct, you have to take. And how much it is? I think this is 6.9 or something, 6.89 or 6.9 something will come. Okay, so this is 6.89 or 9, or this is 0. This control limit already you know, that is 2.3. Yes or no? Yes. Now put all the data, correct? Just putting all the data, what you will find? Suppose 1 0 is there also, like that. So is any point crossing the limits? No, sir. Sir, one point is on the line, sir, correct? So line belongs to empire. Means what you have to do? This is not crossing the limits, na? Yes. So this is under control only, correct? So in this example, we have learned two more things. If negative sign is there, you have to take 0, and if on the line point is falling, then also you have to consider it is under control. So again, first of all, write down the solution, then I am giving you 6.84 or 848 upper control limit. Okay, so 6.84 I am writing. Okay, thank you. Okay, .84, right? So it's very simple. Yes, Karthik. By default, we take 3 sigma if it is not mentioned. No, this is not a part of technical question, technical syllabus in any branch, right? This is in GS only. Done. So again, write down the part conclusion. Please write down the comment. Not a single point is crossing the limits, and the pattern is random. So process is under control, and the causes of variation or causes of defect is common variation, random variation. The same thing you have to copy it. Same thing you have to copy it. Please copy it. लिख लो फटाफट. यस, लिख लीजिए. पंकज इज आस्किंग सर वेव किस डेटा के अकॉर्डिंग बनाई है डिफेक्ट्स. ये वेव क्या पूछ रहे हो भाई. चलो ठीक है. ये सारे पॉइंट्स मैंने रख दिए हैं. करेक्ट जो दिया था ना, नंबर ऑफ डिफेक्ट 2 3 0 जो जितने भी थे, आई हैव केप्ट ओवर देयर. राइट नाउ आई थिंक यू आर just able to conclude control chart and uses of control chart. Now I am moving ahead. थोड़ा सा और आगे बढ़ रहा हूँ. Means now I am going to conclude about the quality of the process, whether the process is capable or not. That is called as process capability. ठीक है, अभी तक हम लोग देख रहे थे कंट्रोल में है या नहीं है, अब हम देखेंगे कैपेबल है या नहीं है। गेटिंग माय पॉइंट? टू थिंग्स आर डिफरेंट। कंट्रोल में होना दैट इज डिफरेंट, कैपेबल होना दैट इज डिफरेंट। हाउ सर? जस्ट आई एम गिविंग यू वन एग्जांपल। A 10th student suppose is in control, full control, but he is not capable to solve engineering services questions. Yes or no? Yes. So this is capability. Now come to control mein hona. Suppose a student who is going to top the table in engineering services, suppose this year. Suppose preparation is ultimate, just getting rank 1 2 rank 1 2 in all the test series, right? But before examination in that night went for parties, correct? And in morning they returned from the party. Now the mood is correct, suppose whole night party is there, so not able to focus on the exam and get rejected. So now as a friend, what you are going to suggest him? कैपेबल बनो? नहीं, कैपेबल तो वो था, टॉप कर सकता था, बट व्हाट यू आर गोइंग टू सजेस्ट हिम? कंट्रोल में रहो। यू आर कैपेबल बट यू वेयर नॉट इन कंट्रोल। एग्जामिनेशन से पहले कोई पार्टी करने जाता है क्या? Yes or no? Yes. So capable में होना, control होना, these two are different things. So right now in these two problems what we have discussed, whether the process is under control or not, means only causes of variation, random or assignable. That's it. But now I am going to discuss if a process is capable or not. Correct? Process capability. Right? So again one question I will give you. Okay, do one thing, take a break first, then I will discuss that, right? Yes, this is the question. It seems it is a big question. Of course, it is a mains question, but only in 2 lines we are going to solve this question, in 2 lines only, right? But there are so many things we can extract from this question as far as objective is concerned, right? But solution will be in 2 lines, so don't be afraid, correct? डरना नहीं, but थोड़ा कुछ सिखाना है मुझे, वो मैं चाहता हूँ क्वेश्चन से आपको सिखाऊं तो चीज़ें जल्दी समझ में आएंगी, correct? So you can write down the problem or take a break, and then just after break we'll come and solve the question, right? चलिए 10:22 हो रहा है, हमें आना है, just 10 मिनट में आ जाओ, right? Please come after 10 minutes break.